Sauce here. This is a video lesson on using algebra properties. We're not going to use every one. We're going to use some important ones. But this is a lesson more how to approach a problem and access the resources that can help. I'm going to work some examples. Our first is x plus 3 all squared minus 4. If you were asked to simplify or distribute and simplify, combine like terms, and you got stuck on how to square a binomial, how do we multiply x plus 3 times itself, then you might get some help from an algebra property, a general form, and how to deal with the situation that we see. So what is the situation that we see? We want to be reminded how to take the sum or difference and then square it. We've got some names for this in Algebra 1. We could call this foiling, but in general it's distributing, multiplying an expression or two expressions. In general, a plus b all squared will be a squared plus 2ab plus b squared, no matter what a and b are. A and b could be numbers, they could be variables, or they could be expressions combining variables and numbers. This is a property, and we can apply it to the x plus 3 all squared. When we do, we're thinking of x as the a part in the general expression, and 3 as the b part, and we follow the pattern. This is going to be x squared plus 2 times whatever a and b are, in this case x and 3, plus b squared, in this case it'll be 3 squared is 9. And then of course I'm still also subtracting 4. Now that I've applied the property, I can simplify and combine like terms. When I do, I can finish up with x squared plus 2 times 3 is 6x, and 9 plus a negative 4 is 5. Let's do another example. We may be asked to simplify something like 2a squared b cubed all cubed. A lot going on. If we were to look at this and think, what's the answer? We might lose confidence because there's a lot of power properties going on. So let's think about the general form. We can see first, before we consider the cube outside the parentheses, that we're multiplying a number and a couple of powers. So we might look to a general property in our notes or resources and think, how do I multiply two powers? And we could be revisited in our notes with a property of powers, a base to an exponent times another power of the same base to another exponent can be simplified as that base to the sum of the two exponents, in this case n plus m. This is a power property. It'll work for any base and any exponent n and m. But in being reminded of this property, we can see it's not going to apply here because these two powers, a squared and b cubed, are not the same base. So we're reminded that we cannot simplify that piece. Good to know. Trying would cause an error. What about the fact that we are cubing something inside parentheses? And what's inside parentheses is a product. Let's take a look at a general property. If we have a product, two things multiplying each other, raised to a power, then we can think of that as the equivalent expression, one of the factors in the product raised to the power times the other factor raised to the same power. And with this property, we can see we can apply it here. The power that we're raising each of these factors to is 3. And we've got 3 factors in the product. The product is 2 times a squared times b cubed. So this 2 is going to be raised to the third power. And the a squared is going to be raised to the third power. How do I do that? It's another property. How do I take a power and then raise it to another power? The property tells us we can simplify. It's the same base to the product of the two powers. That tells me how to take a squared and then raise it to the third power. It's going to be a to the 2 times 3, which is 6. And I'm going to use the same property to take the b cubed factor and raise it to the third power. It'll be b to the 3 times 3 is 9. I can simplify just a little bit more here. The 2 cubed will be 8. And the a to the 6th, b to the 9th do not combine. They're not the same base. And I've simplified as far as I could. One more example. We could be taking the square root of something fairly complicated. Square root of 4x squared y to the 4th. What properties are going to help in this case? Well, what's the general form of what I'm dealing with? I'm taking the square root of the product of 4 and x squared and y to the 4th. So I look in my notes to remind myself, how do I take the square root, or any root, of a product? Radical a times b. And the algebra property tells us that we can separate the factors under their own radical. The radical of a product is the product of the radicals. How does it apply here? Well, I can use a square root for the 4, multiply by the square root of x squared, and the square root of y to the 4th, and deal with each of these separately. The square root of 4 is going to be the value 2. The square root of x squared, you may be reminded of the property that the square root of x squared are inverse operations that leave x. That resolves the square root of x squared. But what about the square root of y to the 4th? Another property to be reminded of, the square root of any power can be thought of as the base of that power to a fractional exponent, where the numerator is the power and the square root becomes a denominator of 2. Raising something to the half power is the same thing as square rooting. And if we combine that with the power of n, then we get this result. Let's apply it here. The power base is y, the exponent is 4, and the square root is going to become a half. Now that I'm seeing it as y to the 4 over 2, 4 over 2 is 2, which simplifies to y squared. So my final answer is 2xy squared. In these examples, we reviewed a number of useful properties. But the idea is to approach the math with an understanding of where you're getting stuck, what form the algebra is taking when you're stuck, and then looking for a property that shows you how to deal with that form. These properties change the form of an algebraic expression into another equivalent form, which may be helpful. And of course, properties could be used in reverse. If we start with the product of two radicals, we could go backwards and wrap it up like that.